Okay, hello everybody. I hope you are having fun with Thanksgiving, and I hope you don't forget to watch this video before Monday. In this video, we're going to go over, well, I guess you need to fill in some of the blanks on your green formula sheet, and then I'm going to show some examples of how to evaluate trig functions, how to simplify trig expressions, and then how to solve trig equations. Okay, so make sure you fill in the blanks on the top of your green sheet. The following are called identities because they are true for all values of the variable x for which the functions are defined. These identities are used to evaluate trig functions, simplify trig expressions, and solve trig equations. So those three things, they sound like they're all saying the same thing, but there's a slight variation. For instance, if you're evaluating trig functions, here's an example right here of where you might have to evaluate a trig function. In this case, we have if theta is a rotation angle that terminates in quadrant 2 and sine theta is 5/13, we need to find the ratio for cosine theta and tangent theta. Now we've seen this exact same problem before, but I'm going to show you a different way to solve it, which is much easier by using our trig identities. Okay, another example for simplifying trig expressions. With trig expressions, notice we don't have an equal sign. We just want to simplify it as much as possible. So this example here says write an expression or write the expression cosine theta times tangent theta in terms of sine or cosine and then simplify. Most of the time when you have trig expressions, you want to get everything in terms of sine or cosine, and then you just have to simplify it. Okay? And then another situation we might have is where we have to solve a trig equation. And again, you want to simplify them first. Simplify the equation cosine x times tangent squared x times cosecant x equals 1, and then solve on the intervals of 0 and 2 pi. So we've done problems like this example where we had to find all our solutions. That was our last unit. We've done this where we had to find all our trig ratios given a certain information. We've done this in the past. We have not simplified, just simplified expressions before. Okay, so on Monday when you come to class, you'll have a whole worksheet of problems like these three. These three examples are going to be on your worksheet. So if you get a sheet of paper and work these out with me, you'll have 3 of your questions already answered when you come into class on Monday. Don't forget to bring your notes. So let's go over these really quickly. The first example is solving trig functions. So if you look at your formulas or your identities on this green sheet, there are several different ones. We are first going to look at your reciprocal identities, Pythagorean identities, and the quotient identities. And we have to figure out what cosine theta and tangent theta is if sine theta equals 5/13. Well, one of the identities we can use first, and we'll use it very often, is different variations of the Pythagorean identity. So this says use the Pythagorean identity to solve for cosine x, or cosine theta, excuse me. Well, our Pythagorean identity, remember a squared plus b squared equals c squared? We're applying that to our unit circles. So now if I have sine squared plus cosine squared, that's going to equal the hypotenuse of 1. And so I'm going to take my ratio, 5/13, that I got for sine theta, and I'm going to square that and then add it to cosine squared theta and set it equal to 1. Well, I'm looking for cosine squared theta, so I'm going to subtract here. I want to go ahead and square my fraction, and then subtract it. If I plug that into the calculator, I would get 144 divided by 169. And then I'm going to square root that to find out what cosine theta is. Okay, I'm just going to square root that, and I get 12/13. Now remember, anytime you square root something, it can be positive or negative, and the only way you know whether it's positive or negative is because you're going to look at, oops, sorry, it's moving something I didn't want to move. You have to refer back to what oh my goodness, sorry. you need to refer back to what quadrant you're in. In this case, we're in quadrant 2, and in quadrant 2, cosine is cosine is negative. So I'm going to take my negative answer, and then the instructions say use the quotient identity to find your tangent theta. Well, the quotient identity says that tangent theta is sine theta over cosine theta. So I know the ratio we've found for the ratio for tangent theta is y over x. Well, if y is sine theta and x is cosine theta, that's where we're getting this quotient identity. And then, so I'm going to set up my ratios, just plug in the ratios I got here and here into my fraction, into the equation, and then I'm going to simplify, and I find that tangent theta is negative 5 over 12. Okay. Next one, simplify trig expressions. So most of the time, again, we want to write your expressions in terms of sine or cosine. So if we have cosine theta, that's already in terms of sine or cosine, so it's just going to be cosine. Tangent theta can be written as sine theta over cosine theta, and then I can simplify this. Well, if I'm multiplying by cosine and dividing by cosine, those cancel each other out, and so the simplified expression is just sine theta. That's it. Super easy, right? Now this last example, we want to simplify the equation cosine x times tangent squared x times cosecant x, and that's equals 1. We need to simplify that and then solve on the intervals of 0 and 2 pi. Okay, so when we first simplify it, we just want first put everything in terms of sine or cosine. So, and remember everything equals 1. So here, cosine is already in terms of sine or cosine. Tangent squared x is going to be sine squared, oops, I should put x's here, sorry. Sine squared theta over cosine squared theta, and then cosecant is going to be 1 over sine, and that's equal to 1. Now I need to cancel out as much as I can. I absolutely love it when people see sine squared theta up here and sine here, and they cancel out the sines and say that's 2 theta. I have no idea why they do that, okay? Remember, realize that if you have sine squared, you have sine times sine, okay? And so what's getting canceled out is this sine canceled out this sine, and you're left with a sine here. Down here you have cosine times cosine, okay? Cosine squared is just cosine times cosine. That cosine cancels out this cosine, so we're left with sine over cosine equals 1. Well, sine over cosine is just the fraction tangent, and when I set tangent theta equal to 1, I'm going to go to I'm going to do the inverse tangent, or I will go to my trig table, do the inverse tangent of 1, and I find that it is equal to the radians of pi over 4 and 5 pi over 4. So if this equation equals 1, then the two solutions that are between 0 and 2 pi are pi over 4 and 5 pi over 4. Those are the angles I can plug in for my x's in the calculator, and I will get a 1. All right, so I know I went through this very quickly. I hope you enjoy Thanksgiving. Please, please, please take notes, copy these steps down, and be ready to use the 3 identities we went over in the video, the reciprocal identities, Pythagorean identities, and quotient identities in class when you get to class on Monday. All right, bye.